Just by way of overview, I want to look at three arguments for the existence of God. One would be an argument from the origin of nature itself. Then I'll look at an argument from design, and then finish off with an argument from history. And you're getting a perspective from a scientist who is not just happy with finding out that there is some God out there, independent of space-time, that's brought the universe into existence. But as a philosopher, which I also am, I am also interested to find out if this God interacts with humanity. And so that's where the argument from history is going on that one, just make it personally applicable. I want to say a brief word about faith. Many people believe that we should have blind faith. I often am accused of destroying faith because I'm giving reasons to believe certain things, and it should just be faith. There's two types of faith that I would see. First is blind faith, and that's just a leap in the dark. That's a kind of faith where you have no rational justification for putting your faith in whatever it is you put your faith in. And the problem with that kind of faith is that you could put your faith in the wrong thing. And so I argue that a healthy faith is a rational faith, and that is you have some rational justification for putting your faith in whatever it is you're going to put your faith in. So, for example, I have seen people sit in chairs, and I've seen those chairs collapse numerous times over the course of my lifetime. However, the sheer number of people that I see sitting on chairs that don't collapse, coupled with just a quick look at the structure of these chairs, I would say that your faith in these chairs there's very good rational justification for putting your faith in the chair that'll hold you up. But there are other things where the rational justification is not quite as strong, where the step of faith is much larger, and they can get to the extent where it's a blind leap of faith. If you're hanging off a tree limb in the pitch dark in the middle of the night and your friend says, "Let go," you don't know if it's a 1,000-foot drop or it's a 2-foot drop to the ledge down below. That's blind faith. Although, if it's your friend, chances are you've got some rational justification for thinking that your friend might be leading you in the proper direction. So that's about all I have to say about that, and what I'm going to argue is for a rational faith. It's not the blind leap in the dark. So let's begin with the argument from the origin of nature. There's this idea, well, first of all, it appears, just from our own observations of the universe, that the universe itself had a beginning at some point in the past. And Einstein's general theory of relativity links together as inseparable space-time, matter and energy, and so you cannot have just a beginning in matter and energy, but when we talk about the origin of the universe, we're also talking about the origin of space-time itself. Now, there's different theories about what that origin looks like. It could be a singularity, or it could be other extended situation, as in the P and Stanton approach, where you don't have just a singular beginning to space-time. However, one of the things that it does seem it does seem almost obvious, but perhaps not to the point of where we can say it's a fact, is that the space-time, matter, and energy does appear to have had a beginning in the past at some point. But even if we didn't have that information, there are other reasons to believe that time, past history itself, cannot be infinite. And it has to do with the impossibility of traversing an infinite series if each step in that series requires a certain amount of time greater than 0, and that certain amount of time remains a constant. So say, for example, hours. There cannot be an infinite number of hours in the past. And during the Q&A, you can ask me more about that to expand on that if that doesn't make sense to you. But there's some references for your own enjoyment. Now let's begin with this origin of nature. If something has a beginning to its existence, then it must be caused by something. And our whole system of science is based on this, this causal principle, and not just science, but logic. We see the causal principle operative in logic, in logical deduction. We see the causal principle operative in mathematics as well. But there is the other option, of course, is that things can begin to exist with no cause at all. And so, for example, if we heard a loud bang out in the hall, someone could say, "What caused that bang?" And I could simply say, "Nothing." But I would argue that that's an irrational answer. It doesn't make sense to us. It's also definitely a science stopper, because the moment you say that this effect here has no cause, you immediately excludes science from having anything to say about that effect as far as explaining it, explaining how that effect originated or began. So in general, I'm working under even in quantum mechanics, that everything that has a beginning to its existence must be caused by something. Nature, it appears, had a beginning to its existence, and therefore it logically follows that nature must be caused by something. And that's the problem. What is that something? If you grant the first two propositions, and the probability that they are true is that they are both true is very high. We can't say it's 1, but it is very high. Then you have to logically grant the conclusion, proposition number 3. So now we come with a dichotomy here. The cause of nature must be either natural, that is, it caused itself, or it must be non-natural, in other words, it's supernatural. So those are our two options. But the 5th proposition states that nature cannot cause itself to come into existence. In logic, there's this fallacy known as the circular argument, and that occurs when you assume your conclusion in your opening premise to prove your conclusion. And of course, that's a fallacy. Yet I see many very, very intelligent people trying to find a natural explanation for natural explanations. Natural explanations are entirely based on space-time, matter, and energy and the laws of nature, which it appears to us had a beginning to its existence. So we have an effect here, that is nature, and we have to explain what caused nature. Now there are other approaches. For example, some people would postulate that there are many universes. Our universe is just perhaps the result of a quantum fluctuation at the event horizon of some other universe, and it goes on. But even in that scenario, you cannot have an infinite number of universes going back into infinity past. Under that scenario, you still must have a finite series to traverse. And so when I'm talking about physical reality or nature, if you say this universe is a one-off deal, then nature is space-time, matter, and energy and the laws of nature. But if you hold to the multi-universe theory, then nature would include this whole system of multiple universes. That would be what I would define as nature. And ultimately, even in that scenario, we still must have a beginning. And so nature, we still have to explain what caused nature to come into existence. And since you cannot assume the existence of nature in your opening proposition to prove that nature caused itself, which is logically impossible, you have to go with the second option on the dichotomy. It's something non-natural that brought nature into existence. Non-natural, which I am also referring to as supernatural. If you grant proposition 4 and 5, then the cause of nature must be supernatural, must be a non-natural cause. And I'm going to call that alpha for the time being. Now, since alpha caused physical time, alpha must be able to exist independent of physical time. And the reason for that is the same as basically to avoid the circular fallacy again. You cannot assume that alpha is dependent on its existence, is dependent on time for its existence in order to bring time into existence. Otherwise, neither will ever exist. That's a circular fallacy if we're going to assume that alpha is contingent on time and therefore is able to bring time into existence. Whatever alpha is, it exists in a reference frame within which there's no time. And that being the case, it follows that it must be timeless, but it also must be beginningless. Let's postulate a reference frame. This is our space-time continuum here, and here's the ultimate reference frame. We're going to call this reference frame alpha. We have space-time in this area here, but in this area here, there is no time. But if you're going to ask, what caused alpha, or did alpha have a beginning, what you're immediately assuming there was a time when alpha did not exist. Then something caused it, and now it exists. But of course, there is no time here. You cannot have time here in order to bring time into place here. So therefore, it follows from that alpha is timeless and beginningless. And it also follows from that it cannot be caused by anything. Because the moment you say, well, what caused alpha, you're assuming there was a time when alpha did not exist, then something caused it to exist and now it exists. But you've smuggled time back into this reference frame here. And if you really want to smuggle time into this reference frame, then this reference frame here must have a beginning to its existence, and therefore you must also have another reference frame that ultimately has no time. So you're still stuck no matter which way you would like to go. Just using Occam's razor, appealing to simplicity here, I would like to just suggest this universe is a one-off deal. There's no point in appealing to a large number of unseen, untestable entities to explain this one here, if in fact we're now left with explaining the existence of a large number of unseen, untestable entities that we know would have to have a beginning to their existence. Ultimately, you got to arrive at a reference frame within which there's no time, an eternal reference frame. Proposition number 11 is that alpha must have an intelligent mind capable of designing the universe to support life. And here's some figures given by Penrose that suggest that the probability that this universe is an accident is that number right there, 10 to the 10 to the 123rd power. And that's why many people would postulate that there are almost an infinite number of universes. It's not actually an infinite number, but a very large number. And if you have a very large number of universes, then probability that you get one that's capable of supporting life, then approach it, well, it gets a lot better. Maybe it gets closer to 1. He's not suggesting that here. He's just coming up with some figures, and these figures change all the time, so I wouldn't bet the farm on these exact numbers because they're constantly changing the more we learn in theoretical physics. Proposition number 12 is just gathering together these sub-conclusions, concluding that alpha is an eternal, uncaused, and an intelligent creator of the universe. However, that is God, and that's analytically true. Analytically true means it's true in virtue of a generally accepted definition for God that's found across many cultures throughout history and throughout many religions as well. It's not necessarily a Muslim God or a Christian God or a Hindu God. It's not, that's more a detailed, more specific notion of God, but this is a general notion of God. With that in mind, the logical conclusion is that the cause of nature is God. That is, an uncaused, eternal, and intelligent creator that had some point in mind for the universe, and that point seems to have something to do with life, in virtue of the fact that the universe appears to be incredibly fine-tuned such that it is capable of supporting life. That is a very quick argument for the existence of a general notion of God from the origin of nature itself. And Hawking makes a little statement there about some possible religious overtones and how scientists prefer to shy away from the religious side of it. Now I want to look at an argument from design, and what we see here is a molecular machine, kinesin, walking up a microtubule, and kinesin transports material from the central region of the cell into outer regions of the cell, and the load is attached to the top. There are many of these molecular machines. This is a very simple one compared to many molecular machines in your body right now, and we'll see a little bit more about that shortly. First of all, a paper published just a few years ago arguing that chance and necessity do not explain the origin of life, and the reason that they hold this is that all known metabolism is cybernetic. This is the abstract, this is their concluding sentence in the abstract. And this is their reason. It's cybernetic, that is, it's programmatically and algorithmically organized and controlled. Essentially what they're saying is it's computer code. And computer code requires that for every point in that code there is a decision being made. And whatever is producing this code must be aware of the different options at each switch point and be able to encode this into the genomes of life. This is the basic summary of their argument. Now, that's just meant to pique your interest. It's not, of course, the fact that two people published a paper saying that, doesn't mean that we should all immediately abandon everything we believed. I want to use an example, however. This is an example of a protein, and to the uninitiated that may look like a bit of a rat's nest, but in reality, about 75% of the proteins in life are composed of a sequence of amino acids such that they fold into a stable three-dimensional structure, something like that. And each structure has its own particular capabilities as far as carrying out some sort of a function within biological life. And some of these structures are so precise that even a shift of an angstrom or two will render it non-functional. Something else you need to know is that the number of sequences that will actually code for amino acid sequences, I should just back up a step, Typically in proteins, there are a sequence of amino acids, and there are about 20 different amino acids. There's 23 found in organic life, but 3 of them are pretty rare. 20 that are commonly used. And so imagine the combination to a safe where you have the average protein has 300 amino acids, 300 to 400 amino acids. So imagine trying to break into a safe where there are 300 numbers, and for each number it goes from, let's say, 0 to 19. So you've got 20 options for each number, and there's 300 of them. That's the average protein. And now typically, unlike a safe where there might be only one combination that will open it, for the average protein there might be a very large number of combinations that will give you the same structure. But in comparison to the number of possible combinations, there are virtually almost 0 combinations that will work. And we'll see some examples shortly. So the other thing that you need to be aware of is that these structures are determined by physics, not biology. And so what biology must do in an evolutionary search is search the sequence space of all possible combinations and find the right combination. So it's really a search problem. If you're going to hold to a Darwinian evolutionary view of the origin and diversification of life, it becomes a search problem in sequence space. With that in mind, we need to know what sort of boundary conditions are involved in this search. And here's some fairly generous parameters. And the bottom line is found here, is that at the most, the total number of trials that will have been available for organic life, if it's been going on for 4 billion years, is about 10 to the 41 trials. That's total for all of organic life. Assuming right off at time 0, you've got 10 to the 30 members in your population, which is estimated to be the total number of life forms on the Earth. Maximum number of generations between you and the first life form is 10 to the 14 generations. So all of this evolutionary search to find all these different proteins, and there are thousands of them, must all take place in 10 to the 41 trials. One of the problems, there are a number of problems with this, but one of the problems is that in these proteins, you can sometimes break them down into modules. Well, I'll call them modules. They're commonly known as structural domains. What that is a section of the protein that will achieve its three-dimensional structure independent of the rest of the protein. And so if you get 2 or 3 of these modules together, they can form the larger protein. And Axe has published some work to try and figure out how often these occur in sequence space. And the best case scenario is about 10 to the minus 64th. In other words, when you look at a set of all possible combinations for the average structural domain, only about 10 to the minus 64th, there's a subset that would be about 10 to the minus 64th of the entire set of possible solutions. And so what you're seeing here is that the target that you're looking for in this evolutionary search is very small. But recall that we only have 10 to the 41 trials in 4 billion years. And so right off the bat, we see we're about 20 orders of magnitude short of what we would require to find even one structural domain, and we need thousands. That's the cold, hard reality that an evolutionary search is facing. So when you hear people confidently talking about how this search did this or that or the other thing, most of the time they haven't even stopped to figure out how many trials are available. In my experience, they have not sat down, and they will not be able to tell you how many trials are available to this search. Here's another way of looking at it. If we're looking at it in units of information, the step size between different structural domains, I would call this a domain set, because sometimes, or perhaps often, we're not sure just how often this occurs. The same sequence will code for maybe 2 or even maybe 3 entirely different folds. You're locked into those 2 or 3, however, depending on how the folding goes. So the difference between, typically, just using Axe's work of 10 to the minus 64th best case scenario, you would need about 213 bits of information to find the next island. If you're going to think of this in other terms, if the top of this island was 1 square meter in area, and that includes all the sequences that will code for that particular structure, the next nearest island is tens of millions of light years away. That gives you an idea of just how difficult this search is, how impressive it is, what sort of challenges an evolutionary search has available to it. I won't talk about Lenski's simulation. If you're familiar with that, you can raise it, but their step size was radically way too short. Does not really reflect reality. There's a way to check this for yourself. I'm actually giving a lecture on intelligent design on Wednesday, where it's really focused on an argument for intelligent design using a method for ID detection, which is entrenched in science, despite what people might say. We already use ID detection in many ways. In fact, I was using it back in the 80s. Actually, no. It was the 70s. I was working for National Defense Research, writing code that monitored underwater sounds and would filter and look for sounds that were made by Soviet submarines and filter out all the sounds made by natural processes. So it was essentially an exercise in intelligent design detection, in separating all the things made by natural processes, all those sounds, and then looking for just the sounds that might betray human presence under the ocean of some sort. That was back in the 70s. It's also heavily entrenched in SETI, for example. Of course, they're looking for signals that will betray an intelligence out there. Forensic science, it's central to forensic science in distinguishing whether an event or an effect is produced by natural causes or by, what's the typical term? I can't remember the legal term that's often used. And it's also used in archaeology, say ground penetrating radar. You have to distinguish now, is that an ancient buried wall there, or is that just a volcanic dike, or what is that? And so there's constantly this ID detection that goes on in science. Now it's involved in biology as well, as some of you may be aware that the Ventnor Institute has built a genome from scratch for M. genitalium, but they've put 5 watermarks built into that genome that have some of the scientists' names in there encoded. And so now it's an issue in biology. We got to look at DNA and say, is this section of the DNA produced by intelligent design, or is it just natural processes? But I'll get on to that Wednesday, and how we can actually use a scientific method to apply it to any effect and determine whether it's a product of intelligent design or not. But what I've done in my own research is I am looking at information encoded in biopolymers. So one of the things I need to know is how frequent, say, these are 2 universal proteins, and they're roughly average size, maybe a little lower than average size. And it's a way to determine what portion of sequence space they occupy, and you can see that they occupy a very small portion of sequence space, 10 to the minus 250, 10 to the minus 207. So the first life form, which would require, actually, there's a more recent paper here that bumps it up to even more genes, but this is the paper that I have found that has the lowest number of genes. The probability of finding that is about 10 to the minus 30,000. Now the standard way out is to appeal to natural selection, and for most biologists, when they're appealing to natural selection, probably are not familiar or have not written a lot of genetic algorithms. And it's very helpful if you're in biology to take a course in genetic algorithms. What you will soon find out is a genetic algorithm will not work without a fitness function encoded within the algorithm to guide the algorithm to find what the solution you're looking for, or at least find an approximation of the solution. And so natural selection is not exempt from that. Natural selection is really assuming there's some sort of fitness function encoded within nature itself, that the outcome are these proteins. In fact, you don't stop there. They got to be there's got to be some larger system within which they can achieve a function, eventually molecular machines and so forth. So the fitness function or natural selection does not get you off the hook simply because you have to ask the same question: is intelligent design required for the fitness function? And you can get an estimation of how much information is required to encode in that fitness function by the amount of information you require as an output, in this case, finding all the proteins in sequence space. And when you do that, it becomes very obvious that natural selection, if it's going to do everything that it's being asked to do, will require an immense amount of intelligent design input to encode the information into the fitness function of nature to build life, if you want to go that route. Now, other people will suggest that I have, these probability problems are just some warmed over argument from a long time ago that's been dealt. No, it has not been dealt with. In fact, it's becoming a larger problem now as more and more biologists are becoming aware of just how rare in sequence space these proteins are. So Kuhnen just published a paper just middle of last year. His solution is that there are perhaps an infinite number of universes, or there are a large number of possible worlds. And if that's the case, then we could explain how life arose against such improbable odds. Now, the reason that I put this up here, this is the most recent paper, is to respond to the people who would say, no, the probability problem is not really a probability problem. I'm just making it out to be one. No, it is a serious problem, and I don't have to take Kuhnen's word for it. I've written some software that actually analyzes aligned data sets for any protein you want to punch in there. And so you can actually come up with the individual probabilities of various proteins, what portion of sequence space they are. It is a serious problem, a major problem. What's interesting are the responses by the reviewers, which are also published online. One of their responses, one fellow here comments, he says, a good hypothesis here needs to be testable, refutable, which the many worlds is not, of course. You can't test or refute other universes apart from ours. It needs to be minimal, which is, again, the many worlds hypothesis fails because that's exactly the opposite of being minimal. You've got a large, very extremely large number of unseen, untestable entities. But your origin of life theory also needs to be probable, and this is where standard scenarios for origin of life fail. So either case, there is a serious problem if you do not want to admit to design of any sort. More rational explanation is that a distinguishing attribute of intelligence is the ability to produce significant amounts of functional information or functional complexity. Trust that that's evident, but I'm here all afternoon for questions. Natural processes can produce only very low-level functional information, and there's actually different scenarios you can run to estimate what level it can, and it's very low. There are various numbers that come up. Average protein requires about 700 bits to locate, and we need thousands of different. Nature itself, probably for organic life, and I've got some scenarios, I think Wednesday I'll be running through different scenarios. Probably around 138 bits is extremely generous as far as what nature could produce. 138 bits of functional information. Intelligence can do that. We know it can. Every time you write an essay, just one page of that essay is more than 700 bits of functional information. So it's not like, oh, we don't know what can produce functional information, therefore God must have done that. The argument is not that way at all. The argument is we already know that intelligence can produce basically unlimited amounts of functional information. We already know that. The question is, can natural processes do it? Because if they can't, we got to go with what we know, and what we do know is that intelligence can do it. Conclusion, science has failed thus far, and I think I'm being very generous. We're even putting the phrase thus far. It will fail to explain the information for coded proteins, how it became encoded with the genomes of life. And the reason that it will do that is not the fault of science, it's the fault of natural processes themselves. They're extremely limited. In fact, one of the, interestingly, in the course in genetic algorithms, or early in the course, my professor giving us the history of genetic algorithms said they were initially modeled on evolutionary processes, but he says if we just use natural selection and the evolutionary fitness function there, our genetic algorithms will never do anything. So genetic algorithms today are much, much more sophisticated. Our genetic algorithms, the ones developed by intelligence, are much more sophisticated than anything you'll see in nature. Now let's get down to practical reality. This is nice to find out that there might be some sort of an intelligent creator out there that's uncaused, eternal, but intersects our space-time continuum. But is this entity, is it of any practical relevance to us? So I want to do an argument from history just quickly here in the last few minutes. If anyone in history has both claimed to be God and offered sufficient warrant for us to believe she was telling the truth or he was telling the truth, then we have warrant for the belief that God exists. Now, numerous people claim to be God, many of whom are in obvious need of psychological help, and so that's why this warrant is important here. Now, the idea, here's my argument. Jesus of Nazareth claimed to be God. There is warrant for the belief that he was telling the truth, and therefore there is warrant for the belief that God exists. And keeping in mind, the blind leap in the dark and avoiding that and the need for rational justification, that is why you need some warrant. So what is the warrant? Unfortunately, however, there's been a lot of stuff going on a very unscholarly level by Dan Brown and so forth. Jesus never existed and so forth. So these are just some quick little historical things about Jesus from historians who lived at the time who were not Christians. Tacitus was a Roman historian, so was Josephus. Josephus was also a Jew, not a Christian, but a Roman historian as well. This idea that Jesus had risen from the dead was not something that evolved over 100 years, but it was something that the people immediate to the time, and he lived at the time of the explosion of Christianity in the Roman Empire, the people right there believed that he had risen from the dead. It wasn't a late belief. He was also familiar enough with the ancient prophecies concerning the Messiah to allow that perhaps Jesus was the Messiah. He doesn't actually make the conclusion that he was, he just says perhaps he was, and that some called him the Messiah. The earliest part of the Talmud has some sections that are controversial, as are they talking about Jesus of Nazareth or not. However, there's one or two sections that mention things that seem to be so specific to Jesus of Nazareth that it appears that that is who they're talking about. Crucified on the eve of the Passover, judged to be guilty of sorcery. Here we have external confirmation that Jesus did do miracles. They never argued that. What they argued was his source of power. You see those discussions in the New Testament documents as well as later on in this here. You see the impact that he had. He led Israel, the entire nation, it says, into spiritual apostasy. Relative to the leaders who were strongly opposing him, they would have called that apostasy. Back to the argument. Jesus of Nazareth claimed to be God, and he really made some quite remarkable claims that are a matter of historical record. First of all, he claimed that he's always existed, never had a beginning, always existed. He claimed that he came to take the demands of perfect justice for all the sins of humanity upon himself. Basically, he was saying that we have been created to have a personal relationship with God, but because of our own moral infractions, a part of us has died inside, a spiritual component. And as a result, since God is a spiritual being, we're spiritually dead. We can't have a relationship with God. So somehow that needs to be dealt with. He claimed that he was the solution to that problem, that he could actually give us life and also pay the demands for justice for all of humanity. Because the perfectly just God cannot, just like some banana republic judge, let everybody go free who he likes. There's got to be still some justice demands, and he satisfied. So he took his own demands of justice on himself. He also claimed that the eternal destiny of every human being is determined whether or not that person will accept what Jesus has done for each one of us individually, as far as sacrifice for sins and this gift of eternal life. So we have a situation here where we have a person claiming to be God, making very remarkable claims, even regarding each one of our eternal destinies in this room right here. And it all hinges on what we do with him. So the next thing we need is warrant for taking his claims seriously. And there are two lines of warrant that I would suggest. The first is the fulfillment of ancient messianic prophecies. I'm being conservative when I say dozens. They're actually the same. So many of the prophecies are repeated many times, and so I'm just compiling them down into dozens. Are recorded before the time of Christ. Now, when I was actually getting interested in this about age 17, I thought the Christians had got a hold of the Old Testament, wrote their own version of it, including writing in all these ancient prophecies, so-called ancient prophecies, to make Jesus look good. But then, of course, as a high school student, I found out about the Dead Sea Scrolls, which contain many parts of the Old Testament that actually predate the time of Jesus of Nazareth. And they have the prophecies in there. So I knew the prophecies existed before he ever came. Then I found out that the Jewish Old Testament is essentially, Jewish Bible is essentially from the same Hebrew manuscripts as the Christian Old Testament, and the prophecies are in there as well. So these ancient prophecies are admitted to not just by Christians but also by Jewish scholars, and there's historical evidence that he actually fulfilled those prophecies. And again, that's not just Christian scholars saying that. It's scholars who are not Christian, and it's also Jewish scholars. And some of the Jewish scholars say, as a result, that perhaps Jesus was the Messiah for the Gentiles, and the Jewish Messiah is still yet to come. Now, the second line of warrant, so it's the ancient prophecies that Jesus fulfilled against impossible odds, unique amongst all the religions in the world. In fact, it's unique in history. The second line is the historical evidence for the resurrection from the dead. I'm only going to refer you to two scholars here. William Lane Craig, who did his PhD at the University of Munich under Wolfhart Pannenberg, specializing in that area, and also a Jewish perspective, Pinchas Lapid, a Jewish scholar, who also concludes that this resurrection from the dead was an historical event. It was a very real event, and it wasn't an invention of the disciples. It actually occurred, and his suggestion is that he's the Gentile Messiah for those who. So I recommend, but just quickly, 3 reasons they come to this conclusion. The empty tomb would have had to have been empty, and I'm just rattling by very quickly here because I want to finish in about 1 minute. His resurrection appearances would seem to be by hundreds, and the explosion it was a detonation, more accurately. Within weeks, there were many thousands of people in Jerusalem against fierce religious opposition believed he had risen from the dead. He was giving public lectures to groups as large as 500 after his death and resurrection. It's, again, unique in history because there is no other religion that detonates that quickly. So in conclusion, the argument goes as follows. And personal experience, bottom line is there's still a step of faith here. I've just given you some reasons to believe that possibly this is all so, but you will not know whether this is actually true until you personally experience God by putting your faith in Jesus Christ for forgiveness for the sins that each one of us has committed and eternal life.